So yesterday we did kind of a basic introduction, and we were given a point and we were given a slope, and that is super nice and super helpful, but that's not always the case. And so I want to take you through a couple more examples where all of a sudden we have to do a little bit more work to really get where we're trying to go. So I'm going to show you a second example to kind of kick things off that's going to build on what our first example was. So we could probably say this is our first example, but it's continued. Or changed, maybe, is a better way to say it. So what we've got here is the line passing through 6, -3. We've seen that point before. And 0, -6. Okay? So as we're going through this, once again, I know that I need point and slope to be able to tackle point slope form. The things I need are in the name. So I'm going to call this my x1, y1. But now I'm going to call this x2, y2. The reason being is, in this problem, they have not given me a slope. And so I need to find a slope so that I can use point slope form. So I'm going to follow the notes that we took on finding the slope, and I'm going to write down the formula. And then I am going to carefully substitute in my ordered pairs. And then I'm going to do some PEMDAS work and deal with the numerator of my fraction, -3 over -6, and reduce that to 1/2. Because now we found a slope. And now we can take that slope and plug it in. So, no slope, find it, then you get to substitute. So that's what makes this first example a little bit different than what we were doing yesterday is we don't have, whoa, that was not a good situation. Let me undo some of that. We don't have a slope in this problem, and so we're going to need to actually come up with what it would be based on the 2 points that we have. So we didn't have a slope, we weren't ready to go, so we found the slope, and then we will continue on our way. So that's kind of how those two examples are related. Let's do one more example. This is a new one, right? This is one that's going to be a little bit different, a little bit different starting point. I want you to tell me about the line represented by this table. So I'm just setting up the table right now. And remember, how these tables work is X is the top row and Y is the bottom row. But that means that every row here is a set of ordered pairs. So every column is a set of ordered pairs. So the first thing I'm going to do is I'm going to pick 2 columns to give me my ordered pairs. Fun fact about Visto, I don't like negative numbers if I can help it. So I'm immediately going to skip over 8 and 16, the -8, -16 row. I'm going to say that I want 6, 5, and let's just use 8, 8. Okay. So those are basically what I've done is I've come up with 2 points here. I'm going to label those 2 points, x1, y1, x2, y2. So the first thing I did is 2 points from the table. Then I'm going to find the slope between those 2 points, right? That's part of why I labeled them. So here we go. m equals y2 minus y1 over x2 minus x1. Y2 is 8 minus y1 is 5 over x2 is 8 again minus x1. It's going to drive me nuts. Minus x1 is 6. So it's 3 over 2. So my slope and your slope is 3 over 2. So now, remember, in order to use point slope form, we need a point and a slope. We're always going to have a point, but it's the slope that sometimes causes a little extra step. So here we go. Here is my point slope form. Remember, when we're plugging in, the x and the y without the numbers by them stand alone, and we keep them. And then we finish by solving for y. So I'm going to distribute my 3/2 in, right? Distribute, and then add or subtract to finish it. So distributing, the y minus 5 just chills. 3/2 times x is 3/2 x. Don't work harder than you have to. Just leave it the way it is. 3/2 times minus 6. So 3/2 times 6 equals 3 times 6 divided by 2. Well, 3 times 6 is 18. Divided by 2 would be 9. Then I said finish by adding or subtracting. In this case, I have to add the 5 so that the y can stand alone. Y equals 3/2 x minus 4. And there is our final answer. Once we get y totally solved for by itself, then we have our answer that we want. That's how we know we're done. So is this kind of a long process? Yes. Is it impossible? No, you can do this. You'll get this figured out. Whether or not I'll get moving these boxes figured out remains to be seen, but we'll keep doing our best. But the idea is you need a point, you need a slope. If you don't have a slope, you have to find one. Then you can plug it in, and then we always finish by solving for y. We do some distributing, we do some adding and subtracting, and you're going to do good things because I know you will. But when you get stuck, if you get stuck, please be reaching out for help. Please allow me the opportunity to help you, to explain things, because I want to take good care of you if only you'll let me. So I hope to hear from you soon, whether it's something good, something bad. Just keep me posted. I miss you guys. You guys are rock stars. We'll talk soon.